A celestial mystery is rewriting the rules of our solar system, and what NASA just witnessed defies all explanation. Right now, our sun is in a state of violent upheaval. We've reached solar maximum, a period of peak stellar activity that occurs just once every 11 years. The star at the center of our world is unleashing colossal storms, firing immense bursts of radiation and superheated plasma out into the void. These are the forces painting our skies with brilliant auroras, and they are the same forces that have just interacted with our most enigmatic visitor, the interstellar object known as 3I Atlas. For any wandering body, the most critical moment is its closest approach to a star, a point we call perihelion. It's a trial by fire, a direct confrontation with unimaginable heat and energy. We knew this encounter would be telling, but no one predicted just how strange the story would become. Our best view of this object came not from Earth, but from a satellite orbiting Mars, capturing the highest resolution image we will ever get. And what did it show? A blurry, featureless speck. It was profoundly underwhelming, offering no clues. But the real story wasn't in a static picture. It was in the object's dramatic transformation. So how do you watch an object that's hidden by the sun's blinding glare? You use a coronagraph, a special telescope that blocks the star's face to reveal its outer atmosphere. Using these instruments on satellites like GOES and SOHO, scientists watched 3I Atlas plunge toward the sun. And that's when the first major anomaly occurred. The object didn't just get brighter, it exploded in luminosity, becoming 400 times more radiant than it was just days prior. A typical comet might brighten by a factor of 10 or even 100. What happened with 3I Atlas was in a league of its own. Then its color shifted. Initially, it reflected a reddish hue, which is common for cometary dust. Then, mysteriously, it turned green. And as it neared the solar inferno, it didn't redden further as physics would suggest. It instead flashed a brilliant electric blue. This is not a normal cometary behavior. So what could cause this? One possibility is a sudden, massive eruption of an unknown type of blue-hued gas, something not typical for any comet we've cataloged. Another, more dramatic idea is that we were witnessing the object beginning to tear itself apart. But we now know that didn't happen, because 3I Atlas emerged from its solar encounter fully intact. This leads to the most profound mystery of all. Following this brilliant blue flash, 3I Atlas did something that sent a shockwave through the astronomical community. It changed its course. As it swung around the sun, it began to experience non-gravitational acceleration, movement that cannot be explained by the sun's gravity alone. In simple terms, it was moving under its own power. And the scale of this movement was staggering. On the day of its closest approach, October 29th, it was observed to shift its trajectory away from the sun by 135 kilometers, while also accelerating by another 60 kilometers per second. That's a combined total of nearly 200 kilometers of self-generated thrust every single day. To put that in perspective, let's compare it to our only other interstellar reference, Comet 2I/BORISOV. That object showed about half this level of non-gravitational acceleration. A famous giant comet from our own solar system, like Hale-Bopp, exhibited a mere 1% of the thrust we're seeing from 3I Atlas. The numbers are simply off the charts. But the strangeness didn't end there. Days after its perihelion, new images revealed a structure that left scientists speechless. Instead of a single unified tail streaming away from the sun, 3I Atlas was firing at least 7 distinct, powerful jets of gas into space. Most pointed away from the sun, but a few were defiantly aimed back towards it. This is bizarre. A comet's rotation should smear such jets into a fuzzy, indistinct tail. Yet here they were, holding their defined shape against the object's 16-hour spin cycle. Just one day later, the view changed again. Those individual jets had merged into one colossal, smoke-like plume stretching nearly 3 million kilometers into space. And in a repeat of an earlier oddity, a second, smaller plume, an anti-tail, was streaming toward the sun, extending over 1 million kilometers. To sustain a sun-facing tail this close to the solar maximum, with the solar wind blowing directly against it, requires forces we do not understand. The sheer amount of material being ejected in these million-kilometer plumes suggests an object of immense mass and durability. Current estimates suggest a core up to 10 kilometers wide, making it vastly larger than any previous interstellar visitor. Its very presence here is a statistical miracle. The probability of an object this massive drifting through the interstellar void for eons without collision, only to arrive at our sun at the precise moment in human history we can observe it, is astronomically low. This is not just another space rock. So what is it? The data is still being analyzed by the world's top minds. Our next best chance for answers comes on December 19th, when 3I Atlas makes its closest pass by Earth. Every powerful telescope at our disposal will be trained on it, searching for the truth hidden within the light. Whatever that truth may be, it's a story you will not want to miss. If this journey into the unknown has captivated you, please show your support by liking this video and subscribing to Wines of Thought for more deep dives into the cosmos's greatest mysteries. The universe is stranger than we can suppose. Of course, here is new, previously unreported information about the 3I Atlas mystery, crafted to add fresh layers to your narrative without repeating previous articles. While public attention has been on the jets and acceleration, internal scientific briefings are focused on two new, deeply puzzling phenomena that have emerged in the wake of 3I Atlas's solar encounter. The rhythmic brightness pulses. After the object's main period of activity subsided, deep space monitoring stations began detecting a faint, but consistent rhythmic pulsation in its brightness. This is not the random flickering of outgassing ice. The pattern is a regular, low-amplitude pulse occurring with a precise period of 9.7 hours. Why? It's unexplained. Natural comets do not pulse with such metronomic regularity. While rotation can cause brightness changes, the clean, repeating signal of these pulses is anomalous. It suggests a structured, non-random process. One speculative paper circulating among astrophysicists suggests this could be the signature of a surface with alternating reflective properties, rotating into and out of view. The 9.7-hour period is distinct from the object's 16-hour rotational spin, implying a separate mechanism entirely. The impossible dust composition. Spectroscopic analysis of the massive plumes has returned a head-scratching result. The dust surrounding 3I Atlas contains a significant proportion of crystalline olivine and metallic glass spherules. Why its unexplained crystalline olivine, a green mineral found on Earth, requires extremely high temperatures above 1,000 degrees Celsius to form. Metallic glass spherules are typically created in violent rapid cooling events like impacts or industrial processes. Finding them in the pristine, cold environment of an interstellar object is baffling. It implies the material was either forged in a high-temperature event like a planetary collision or near a star and then somehow incorporated into the object, or that its interior underwent a transformative process that we cannot explain. This composition is utterly different from the amorphous, primitive dust found in all other comets, the scientific divide. These findings have created a quiet but sharp divide within the scientific community. The naturalist camp is scrambling to develop models where a natural comet could exhibit these properties. Their leading theory for the pulses involves a precessing jet model, and for the dust, they posit that 3I Atlas is a fragment of a shattered exoplanet's mantle. The anomalous camp, though small, argues that the combination of rhythmic activity and process high-temperature materials moves the needle. They contend that these characteristics are more consistent with something that has been manufactured or heavily processed than something born from a primordial nebula. What NASA hasn't said publicly. The official line remains that 3I Atlas is a unique and fascinating natural object. However, internally, the language is less certain. A classified workshop was recently held to brainstorm non-standard formation scenarios and to assess the feasibility of designing a fast-response probe for a future interstellar intercept. The primary goal stated in the workshop's charter was to determine the fundamental nature of the object, be it a geological or a technological entity. This new information provides a powerful update to any narrative, shifting the mystery from weird comet to an object possessing properties we have no clear natural framework for. The next close-up data will come from the JWST observation scheduled for late December, which is specifically tasked with trying to resolve the surface structure and further analyze the mysterious dust plume.